What if everything you thought you knew about aging was wrong? For decades, we believed our biological clock was set in stone. But a quiet revolution is happening in the world of science, revealing tiny, powerful molecules that can literally reprogram your body, shield injuries at lightning speed, and even turn back the hands of time on a cellular level. We're talking about peptides, and today we're diving deep into the five most groundbreaking peptides that could be the key to unlocking your true longevity potential. But be warned, this isn't for everyone, and the science is still evolving. Stay tuned to discover if these bioregulators are right for you. Okay, that's a pretty big claim, wait. So let's back up for a second. Before we jump into these specific miracle molecules, what are we even talking about here? What exactly is a peptide? Well, in simple terms, a peptide is just a short string of amino acids, which, as you know, are the building blocks of proteins. The best way to think of them is as tiny, specific messengers. They're like short, clear text messages that your body sends to give a very precise instruction to your cells. They're totally natural, and our bodies use them constantly for all kinds of critical tasks. And that little analogy really helps us see the difference between peptides and their bigger, more complex cousins, proteins. If a peptide is that short, direct message like, hey, start healing this tissue now, then a protein is the giant, complex machine that actually shows up to do the work. It's that small size and laser like specificity that makes peptides such incredibly powerful little tools. All right, now that we've got the basics down, let's get to the main event. We're going to explore five of the most talked about, most exciting peptides in longevity research right now. First up, we've got BPC-157. That stands for Body Protection Compound, and you won't believe where it was first discovered in human gastric juice. Yeah, stomach acid. Its natural job is to protect and heal the gut lining, but what researchers quickly realized is that its regenerative powers go way, way beyond the stomach. And this is where it gets really, really cool. The BPC-157 works by promoting something called angiogenesis, which is just a fancy way of saying it helps create new blood vessels. This basically supercharges your body's ability to heal. We're talking about accelerated repair for tendons, ligaments, muscles, even your nervous system. On top of that, it's famous for its powerful anti-inflammatory and gut healing abilities. But, and this is super important, here's the reality check. Most of the jaw dropping research we have so far has been in animals, like rodents. We're still waiting on those large scale, comprehensive human trials to really confirm its safety and effectiveness across the board. That is a critical step, and for now, it's still a missing piece of the puzzle. Okay, our next peptide, GHK-Cu, is fascinating because it's not some new molecule we're introducing. It's something our own bodies produce in massive amounts when we're young. As we're about to see, the levels of this powerful little guy just fall off a cliff as we age. This one is a real game changer. Studies have shown that GHK-Cu can actually influence the expression of over 4,000 human genes. Think about that. It essentially resets them to a younger, healthier state. It's like a software update for your cells. And what does that look like in the real world? Tighter skin, improved elasticity, stimulating hair growth, and speeding up wound healing. It's kind of a full package. And just take a look at this chart. It tells the whole story. At age 20, your body is swimming in this stuff, right around 200 nanograms per milliliter. But by the time you hit 60, that number plummets down to just 80. And that decline almost perfectly mirrors our body's decreased ability to repair and regenerate itself. It's no coincidence. Now, the caveat here is important. GHKCU's benefits for your skin are so well documented, but it's already a star ingredient in many high end cosmetic products. But using it internally as a systemic therapy for overall longevity and organ health, that's where the research is still an active and evolving field. All right, let's shift gears from influencing our genes to protecting the very structure of our DNA. That brings us to a peptide called Epitalon. It was developed based on a natural substance found in the pineal gland, that tiny but crucial gland located deep inside your brain. Epitalon's main claim to fame is its connection to telomeres. So think of telomeres as the little plastic caps on the ends of your shoelaces. They protect your chromosomes. Every single time a cell divides, those caps get a little bit shorter, and that shortening is a key biomarker at aging. What Epithalon has been shown to do, at least in cell studies, is activate an enzyme called telomerase, which can protect and even lengthen those telomeres. Plus, it may also help restore melatonin secretion, which means better sleep. But it misses a big one. It's absolutely critical to put this in context. While the results in cells are incredibly exciting, most of this research has been done in vitro, which basically means in a petri dish. We are still waiting for robust studies in living organisms, especially humans, to see if these effects actually translate to real world anti aging benefits. A massive part of aging well is having a strong, resilient immune system. And that brings us to our fourth peptide, thymosin alpha 1. It's produced by the thymus gland, which is essentially the training ground for your T cells, the frontline soldiers of your immune defense. So here's a hallmark of aging. Our thymus gland shrinks over time. This leads to a decline in immune function and a rise in that chronic low-grade inflammation that scientists call inflammaging. It's a huge driver of age-related issues. Thymosin alpha 1 appears to counteract this directly by stimulating T cell production and beefing up your body's ability to fight off infections and control that simmering inflammation. And while some studies show it can help older adults respond better to things like vaccines, the much bigger question of whether it can truly slow down the overall aging process in the long term, well, that still needs a lot more research. And that brings us to our final peptide, TB-500. You'll often hear this one talked about right alongside BPC-157 because it's another recovery powerhouse. It's actually a synthetic version of a naturally occurring peptide called thymosin beta 4. So if BPC-157 is great for targeted localized healing, you can think of TB-500 as promoting systemic or body-wide tissue repair. It's incredibly good at reducing inflammation and helps the right kind of repair cells get to an injury site much, much faster. This is obviously new, a major point of interest in sports medicine and for anyone just looking to bounce back faster. So, after that whirlwind tour, let's zoom out. Let's look at the big picture and see how all of this comes together. Beyond what any single one of these molecules can do, why does this field of research really truly matter? What all of this really points to is the potential paradigm shift in how we approach health and aging. For a long time, anti aging strategies have been pretty generic, one size fits all. Peptides could completely change that by offering these highly targeted, specific tools for specific age related problems, whether it's a declining immune system, slow tissue repair, or even genetic expression. This is a huge leap toward a future of precise, personalized medicine. While the science on peptides is incredibly promising, it's crucial to understand. Many of these are still in early research phases, not FDA approved for general use, and should only be considered under the strict guidance of a qualified medical professional. This video is for informational purposes only. Do not self-administer without expert supervision. If you found this deep dive into the future of longevity fascinating, hit that subscribe button and join the Golden Years Pulse community. What peptide are you most curious about? Let us know in the comments below.